Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2023, 10B, Problem 12, and it deals with algebra. I hope you guys enjoyed this video and let's get started. The problem states when the roots of the polynomial p of x is equal to x minus 1 to the 1th power times x minus 2 to the 2 power all the way to x minus 10 to the 10th power are removed from the number line, what remains is the union of 11 disjoint open intervals. On how many of these intervals is p of x positive? So basically what we have here is we have a number line. And it says that the roots of these are removed. So that means that the roots would be each of these sections, x minus 2, x minus 3, x minus 1, that would be equal to 0. So that means that x would be, it'll be at 1, 2, 3, 4, 5, 6. So these roots, all of these are removed. So that means I'm going to denote them as open circles. So that means that the intervals would be the ones in between these, and then from negative infinity to 1, and then 10 to positive infinity. So these would be the intervals. Well, we want to know on how many of these intervals is p of x positive. Well, we notice here that anything raised to the even power will always be positive, regardless of what the number that it's raised to is. If the number is negative, raised to the second power is always still going to be positive. So we're going to focus on the ones with a odd power. So that would just be x minus 1, and then x minus 3, x minus 5, okay, so these are the ones that we want to focus on. Well, to make something positive, to make a function positive, especially when these are all multiplication, we need to have an even number of negative expressions. So that means we can have 0, 2, or 4 negative expressions. And then we can first just focus on the interval of 10 to positive infinity. From 10 to positive infinity, all of these are positive. And this is because, for example, it'll be, for example, 11. That's on the interval of 0 to 10 to positive infinity. And 11 minus all these, 11 minus 9, 11 minus 7, they're all going to give us a positive number. So that raised to the odd power, it doesn't matter because the inside is always positive. And then, so that same logic applies on the interval of 9 to 10. So, for example, 9.5 is on the interval of 9.10. Well, 9.5 as x, substitute that in for x, 9.5 minus all of these, 9.5 minus 9 minus 7, that's all positive. So this is all positive as well. Well, on the interval of 5 through 6 and 6 through 7, because keep in mind that we want 0, negative expressions, 2 or 4. So on the interval of 5 to 6 and 6 to 7, there are 2 expressions. And this is because, for example, 5 to 6, it would be 5.5. Well, 5.5 minus 7 and minus 9, that gives us 2 expressions that are negative. And then 6 to 7, for example, 6.5. 6.5 minus 7, 6.5 minus 9, those all give us a negative number. So this would give us 2 expressions, x minus 7 and then x minus 9. These are the 2 negative ones. And then on the interval of 1 to 2, 1 to 2, and 2 to 3, well, this gives us 4 negative expressions. And this is because, for example, 1 to 2 would be 1.5. Well, 1.5 minus 3, 5, 7, and 9 are all negative. And then 2.5 minus 3, 5, 7, and 9 are all negative. Means that we would have 6 intervals on 10 to infinity, 9 to 10, 5 to 6, 6 to 7, 1 to 2, 2 to 3. So the answer would be 6 because on these 6 intervals, it would give us these 0, 2, and 4 negative expressions. And these are even number of negative expressions, which means that multiplied together would give us a positive, make the function positive. So the answer is 6.